Okay, good afternoon, everyone. We will start our session. Today, we will continue with the unit number 6, remaining part. So, yesterday, we have started with the concept of hydraulic machines, hydroelectric power plant, classification of turbines. Then we saw what is mean by impulse turbine, what is mean by reaction turbine. All these things we have seen. Later, tomorrow you can add these all things on our Padlet. So beginning with the point related with turbine is efficiency. So later in our practicals, we have seen the efficiency means what. So beginning with that, efficiencies of turbine. So first efficiency is called as a hydraulic efficiency. Hydraulic efficiency, and it is denoted by neta H. H is small h. Hydraulic efficiency means what? It is defined as the ratio of power given by the water to the runner of a turbine. You know that runner is rotating part of a turbine and on the runner vanes are fixed to the power supplied by the water at the inlet of a turbine. So in simple fashion, it is nothing but ratio of power delivered to runner and power supplied at inlet. Means it is written as runner power to the water power. In general, the runner power is nothing but power delivered to the runner. And in case of Pelton wheel, it is given by the formula W into VW1. What is mean by VW1? That you will understand in upcoming session. VW2, U divided by 1000 into G kilowatt. Just remember this formula. We will require this formula. We will have to derive it again in upcoming lectures. And water power, which we have seen already, is rho G Q H upon 1000. Where rho is the density, G is the acceleration due to gravity, Q is the discharge, H is the total head acting on the turbine. So water power is rho G Q H upon 1000. It will be also in kilowatt. In general, if we are having a water turbine, rho is 1000, G Q H upon 1000. So 1000 and 1000 will get cancelled, and it will remain only GQH in kilowatt. Like that we can write. So this is the first efficiency, which is called as a hydraulic efficiency. Then second efficiency you should know is the mechanical efficiency. mechanical efficiency neta m, and it is nothing but a ratio of power at the shaft of a turbine, power at shaft of turbine to the power delivered by water to runner. So see, everything is related with the ratio of output on to the input. So if we consider this mechanical efficiency, power at the shaft is output and power delivered by the water to the runner is the input. So it is nothing but shaft power to the runner power. Just remember these definitions. Then third is volumetric efficiency. Volumetric efficiency neta V. Now it is related with the volume. Previously was related with the mechanical properties, like which is nothing but power available at the shaft due to whatever losses are happening, that all losses are considered. And now in volumetric efficiency, volume is considered. Means it is a ratio of volume of water actually striking the runner to the volume of water supplied to the turbine. As you know, in previous diagram we have seen water is coming through the penstock and later it is going to strike on the blades of a turbine, like that. But in between there are some losses. Due to those losses, actual water which is running to the which is striking to the runner will be different from the volume of the water which is supplied to the turbine, and that losses are considered for calculating the volumetric efficiency. Based on that, on these three efficiencies, last fourth efficiency is considered as overall efficiency. Overall efficiency. And it is denoted by neta 0. It is nothing but ratio of shaft power. Shaft power means last to the water power, means at the inlet, which is nothing but finally mechanical efficiency multiplied by efficiency of hydraulic efficiency. So this overall efficiency in general calculated as efficiency overall calculated by P divided by rho G QH upon 1000, where P is nothing but shaft power, and that most of the time is considered. Shaft power is calculated by our experiment. In our experiment also we have considered that shaft power, and that shaft power is either calculated, if it is generating the electricity, then it will be calculated in the form of kilowatt electricity. For experimental purpose, if we are having rope break dynamometer, then by using that rope break dynamometer, we are calculating the shaft power. And water power rho g QH upon 1000, that formula also we have seen already. So with respect to that, you just remember these three efficiencies: hydraulic efficiency, mechanical efficiency, volumetric efficiency, and overall efficiency. Overall efficiency is nothing but it is a multiplication of mechanical efficiency and hydraulic efficiency, and all together we are getting this formula. Then moving forward, where we are going to see the derivation part of the lecture. So last time we have seen the working of a Pelton wheel. That Pelton wheel we will elaborate with respect to velocity triangles. Velocity triangle is the method by which we can see the working of such type of turbines. So here it is a diagram of a velocity triangle, and here this is the cross section area of a blade, and that blade, from here water is striking. Here suppose there is a nozzle, and from that nozzle water jet is coming in this direction and it is striking at this point. Water when strikes that splitter, it is nothing but a splitter, then some amount of water will travel in this direction, some amount of water will travel in this direction. And here some velocity triangles are created. In this diagram, you can see the vanes or buckets of a Pelton wheel. The jet of water from the nozzle strikes the bucket at the splitter, and these parts getting over inner surface and comes out of the edge. So there are two, generally, if we consider the velocity diagram, there are two triangles. One is called as a inlet velocity triangle and another is called as a outlet velocity triangle. But in case of such type of impulse turbines, the inlet velocity triangle is only a edge, and this inlet velocity triangle, which is shown in the diagram, is having only this part. A is the starting point, B is the point where the U1 velocity is there. What is meant by U1, VR1, that I will explain. To see this diagram directly, it is better to have general idea about a curved plate so that it will be easy for you to understand how velocity triangles are drawn. So instead of going forward towards the velocity triangles of Pelton wheel, we will see velocity triangle of in general blade so that it will be easy for you to understand. So here you can see there is a blade. We will go back to the Pelton wheel later. First we will see this velocity triangle. First you can see here is the hatching line shown is the blade. Here is the nozzle. This is blade. Now water is starting from this point. This is the starting point. Then, just a minute. Sorry. Okay. So what is happening here? The jet is starting from point A. In this case, first term comes V1. V1 is this triangle. This is the so it is better. This is V1, and that V1 is known as the velocity of jet at inlet. Velocity of jet at inlet. When water comes out of the jet, whatever velocity with which it is striking to the blade, it is nothing but velocity of jet at inlet. Then second term is known as a U1. This is U1. U1 is the velocity of a plate at inlet. U1 velocity of blade at inlet. Then third part comes is the VR1. VR1 is the relative velocity of jet and blade at inlet. Relative velocity. Velocity of jet and blade. Blade or plate or vane. These words are used. Then next comes the angle alpha. This angle alpha. Alpha is the angle between the direction of jet and the direction of motion of a blade. And it is also called as a guide blade angle. Guide blade angle. Then comes the angle theta. It is nothing but angle made by relative velocity with the direction of motion, also called as a vane angle at inlet. Vane angle at inlet. So you know everything here, it is related with inlet. Then you can see there are two components, VW1 and VF1. This is VW1, this is VF1. VW1 is known as the components of velocity of V1 in the direction of motion and in the direction perpendicular to the motion. Means if suppose this is V1 and that V1, we can have two components. One component is in the direction of motion, that is VW1, and it is in the direction perpendicular, it is VF1. VW1 is known as the velocity of whirl. Velocity of WHIRL, whirl. Remember all these names. And VF1 is known as the velocity of flow. Velocity of whirl and velocity of flow. So all these things are related with the inlet velocity triangle. So water will strike, such type of imaginary triangle will be generated, and then water will move in this direction and it will leave the blade at point E. At that time, what will happen? There is a creation of outlet velocity triangle. And when outlet velocity triangle will created, it will have V2. Now V2 is what? Here V2 is nothing but velocity of jet leaving the blade at outlet. Velocity of jet leaving the blade or velocity of jet at the outlet of vane. Similarly, U2 is what? U2 is nothing but velocity of vane or velocity of blade at outlet. Here is the u2. Then vr2 is nothing but relative velocity. Here it is the relative velocity with respect to relative velocity of jet with respect to when at outlet. Same like vr1, relative velocity of jet and blade at inlet, it was inlet, and vr2 is at the outlet. Then angle beta is there and angle phi is there. Angle beta is nothing but angle made by velocity v2 in the direction of motion, and angle phi is nothing but angle made by relative velocity vr2 with respect to outlet. Similarly, similar to the VW1 and VF1, there are VW2 and VF2, velocity of whirl at outlet and velocity of flow at outlet, which are nothing but components of that V2. This is V2. Here it is the V2. I am drawing here V2, and that V2 has one component perpendicular, one component horizontal. Horizontal component is VW2 and a vertical component is VF2. And this is relative velocity, and when we join remaining it will be u2. Like that we have to draw. If you want to draw a diagram, it will be very easy. How we are drawing the diagram, let's see. I will draw so that you will understand. If I want to draw the velocity triangle, then simple. First we are drawing the blade. Then first we are drawing afterwards the v1, that is velocity which is striking. Then these two components of v1, that is vf1, vw1. Then we will point the value of u1, that is velocity of, it will be from this to this, and inlet velocity triangle is completed. Alpha, this will be theta, and this is VR1. Your inlet velocity triangle is done. Similarly, this is V2. V2 has two components. This is U2. This is U2, and this is tangential VR2. This is VF2. This is VW2. Your velocity triangle is completed. So when you want to draw such type of velocity triangles, you should remember all the terminologies, like what is mean by VF1, what is mean by VF2. You should just remember. I will give in detail notes related with the terminologies which I have explained in detail here, so that you will understand or you can remember all these concepts. Now coming back to our Pelton wheel. So what is happening in the Pelton wheel? So if we compare the velocity triangles about Pelton wheel, V1 is nothing but this horizontal line only. AC, V1 is nothing but AC, because it is striking horizontally. It is not striking in the angle. So that U1 is also horizontal, that is AB, and the component of V1 is only VW1. V1 is nothing but VW1, because there is no component in vertical direction, because V1 is horizontal. If V1 is like this, then it will have a horizontal and vertical component. It is the case which is not present over here. Then whatever things which are remaining is VR1 is also from B to C. But when that water leaves the blade, at that time what will happen, you can observe here, when it is leaving it will be having the same velocity triangle which we have seen previously. So we are having v2, that is velocity of jet at outlet, then we have u2, velocity of blade at the outlet, the components vf1, vw, vf2, vw2 all are there, vr2 is also present. So all these velocity triangles are available with respect to the required positions. In that case, what we are supposed to find out here? So we need to find out some equations related with the Pelton wheel. We have to find out what is mean by what will be the efficiency of this Pelton wheel, and at what just a minute, at what efficiency if we run the turbine, at what speed if we run the turbine, it will give the maximum efficiency, as we did in the practicals. So for that we will see that derivation here, and later we have to design a Pelton wheel also. Just a minute. Okay, so for that, just once again I will paste the diagram, or I will open new page so that we can continue with the new diagram. It is coming. Wait a second. I'm pasting the diagram. Just a minute. Some hanging is going on. Just a minute. System is hanging. Okay. Yes. So what we are supposed to find, the work done by the Now it will come. No. Okay, now it is clear. Yes, I have taken from the book finally. So this is the diagram which I have taken. Here, what we are finding, just we will start with the findings. Consider H H is the head acting on the Pelton wheel, and that H is nothing but Hg minus Hf, where Hg is nothing but gross head. Last lecture we have seen that diagram, and Hf is nothing but our loss, that is 4f Lv square upon 2gd. All the terms you know, that is 4, f means coefficient of friction, L is the length, v square is the velocity of water, and all these things you know. That d star, why d star is given? Because d star is a diameter of penstock, means from where water is coming, and d is nothing but a diameter of wheel. So to differentiate, I have kept it as a d star, and small d we will use as a diameter of jet. Then next concept is n is the speed of a wheel, which is measured in RPM. Now let's see, with respect to all these data, we are finding out the work done. So here from the diagram, V1 is the velocity of jet at inlet, and it is given by general formula 2gh. Then next come U. In case of Pelton wheel, U is nothing but velocity of a blade, and it is equal to U1 and U2. And it is given by the formula pi dn by 60. It is in meter per second. So we are converting RPM into meter per second. We are converting rotational velocity into linear velocity. It is the property of a Pelton wheel that inlet velocity of the blade and outlet velocity of the blade are equal. Then the velocity triangle at inlet is straight line. Here you have seen, and VR1, that is VR1 is equal to V1, this V1 minus U1, V1 minus U1. It is written directly. Or you can write, what we can write? V1 minus U, because U1 is equal to U2 is equal to U. So one more thing you can see from the diagram, VW1 is equal to V1. And another thing which is different from previous one, alpha is 0. and theta is also 0 degree. These angles are also 0 degree. Then we will go for the outlet velocity triangle. Once again, I will take this diagram to the down so that it will be visible for you. Okay. Now we will consider the outlet velocity triangle. In outlet velocity triangle, here, what you can see, VR2 is equal to VR1. That is the another property of what we can say Pelton wheel. VR1 is always equal to VR2. And VW2 is equal to VR2 cos phi minus U2. Means what? This VW2 is nothing but total minus U2. Total is what? VR2 cos phi. This total length is VR2 cos phi minus U2. That is VW2. That is just rearrangement. Then force. We are calculating force exerted by jet of water in direction of motion. And it is given by the formula force exerted by jet in the direction of motion, F in the direction of motion, that is in the direction x, so that Fx is equal to rho a v1 into bracket vw1 plus vw2. So remember, velocity of whirl, which is in this direction, is only responsible for the movement of the blade. When water strikes to the blade, blade is going in this direction. And it is only responsible for the motion of the. As we know, angle beta is acute angle. This beta is positive. Also, in case of series in vein and mass of water striking is rho a v1. It is nothing but rho a v1 is nothing but mass. It is nothing but mass. Mass of water striking is rho a v1, not rho a vr1. That mass, if we consider, then area is where a, here a is nothing but area of jet, which is nothing but pi by 4 small d square. Then if we know the force, we can calculate work. Work is nothing but force into velocity. So what we will get, work done is nothing but finally rho a v1 multiplied by vw1 plus vw2 into u, and it will be Newton meter per second. And if you want to measure it in the kilowatt, we are dividing rho AV1 VW1 plus VW2 U divided by 1000 kilowatt. It was in the watt. Work done per unit of weight striking per second is another concept that we can neglect. And if we want to find out kinetic energy of water per second, it will be nothing but kinetic energy. If we want to calculate kinetic energy, then it will be 1/2 rho a v1 into v1 square. So hydraulic efficiency finally is nothing but work done per second, that is rho a v1 vw1 plus vw2 divided by multiplied by u divided by kinetic energy, that is rho a v1 into v1 square. So altogether, if we cancel the common terms, you will get 2 into vw1 plus vw2 divided by v1 square into u is the hydraulic efficiency of that turbine. But further we can have simplification in this equation from the diagram. What is the simplification? Let's see. This is also finding out the hydraulic efficiency of a Pelton wheel is a separate derivation which will be asked for the 8 marks in the exam. So be careful about this. You have to start this derivation from this point onwards. First, you have to define kinetic energy, then write down the equation of a hydraulic efficiency. Then you have to draw this diagram. Then this diagram will come into picture. So once again, I will keep this diagram for our reference in front of us so that we will have this derivation easily. This will be the final derivation for today. So in this case, we have this equation V2 into VW1 plus VW2 upon V1 square into U. Now in this equation, what we are having, VW1 is equal to V1. Here VW1 is equal to V1. VR1 is equal to V1 minus U1. Okay, this is second, means VR1 is nothing but V1 minus U1, this minus this. Then VR2 is equal to what? V1 minus U, because VR1 is equal to VR. Then we can write VW2 is equal to, we already written all these things, VR2 cos phi minus U2, which is nothing but VR2 cos phi minus U. Again, VR2 is nothing but what? V1 minus U cos phi minus U. So what I have done, put this value here. Now putting all these values in this equation. So just making small. Now what I am doing, I am putting all these values in this equation. So what I will get? 2 into VW1 is what? VW1 is V1. I have put on V1. Then VW2 is what? This all. V1 minus U cos phi minus U multiplied by U divided by V1 square. So what will happen now if we want to simplify it? taking this u1 here, v1 minus u, like only taking one side, plus v1 minus u cos phi into u upon v1 square. So what we can do, we can take v1 minus u common, 2 into v1 minus u into bracket 1 plus cos phi into u upon v1 square. This is the equation of hydraulic efficiency. Now if I want to find out maximum efficiency, then we are taking the derivative with respect to u. So d by du of all the things, that is 2u v1 minus u 1 plus cos phi divided by v1 square and equating to the 0. So what are the constants here? 1 plus cos phi upon v1 square is the constant, and d of du of 2u v1 minus u 2u square is equal to 0. So what will be the derivative? So this will get cancelled with 0. So derivative with respect to only this, what you will get, there 2u v1 square, it's a derivative at 2 v1 minus 4u is equal to 0. So u is equal to what then? v1 minus, so this equation number 2 is the hydraulic efficiency of Pelton will be maximum when the velocity of wheel is half of the velocity of jet of a water at inlet. This expression for maximum efficiency will be obtained by substituting the value of u is equal to v1 by 2 in the equation previously which we have found. That is nothing but maximum efficiency will be equal to, what will be the equation? That is our hydraulic efficiency equation. That is, I will rewrite 2u v1 minus u 1 plus cos phi upon v1 square. In this equation, instead of u, we will putting v1 minus 2. So that is nothing but 2 into v1 minus v1 by 2, 1 plus cos phi into v1 by 2 divided by v1 square. So altogether, when we solve this equation, we will get 1 plus cos phi by 2 as a maximum efficiency of Pelton wheel. So what you are remembering, what you have to remember in case of Pelton wheel. First point, V1 is equal to CV under root 2GH. CV is coefficient of velocity, which is nothing but 0.98 to 0.99. Then second point, velocity of wheel u is given by phi under root 2GH. Here capital H, sorry. Then where phi is speed ratio and it is 0.43 is given, You don't have to worry about it. 0.48. Then angle of deflection is angle of deflection means this angle. Where is the diagram? This angle. Angle of deflection is 165 degree. So sometimes we require that angle of deflection for calculation. So that angle of deflection is 165 degree. I am going little bit fast due to time constraint. Then U is calculated by using formula pi dn by 60 also. Then there is a concept of jet ratio. Jet ratio. It is nothing but, it is denoted by m, and it is nothing but d by d. That is diameter of a wheel to the diameter of a jet. Then 6 is the number of bucket. Z is nothing but number of buckets on the blade. It is given by the formula 15 plus d by 2d. It is nothing but 15 plus 0.5 m. Where the number of jets are obtained by the different requirements of the turbine. With this, we are supposed to design a Pelton wheel, and based on that, we have to consider the formulations. When we are supposed to design a Pelton wheel, what we should remember, that I will explain now. And tomorrow we will see the problems. So if you want to design a turbine, first what we are calculating, we need to find out the diameter of jet, that is small d. Then second, diameter of wheel, capital D. Then third, width of bucket, which is nothing but 5 into D. Then fourth, depth of bucket, which is nothing but 1.2 into D. All these formulas I will give you in the form of notes. Then number of buckets on wheel for maximum efficiency. These things we have to find out, and also find out the power, efficiency, and all other things. So whatever things I have told very fastly during this lecture, all together we have to see. I know I have gone little bit fast, but we only have 3 lectures in our hand, and we have to finish all these things. I will also provide the video of the same lecture as I have provided all previous one. Notes will be given. Remember, this is very simple. If you read once, you will understand all these things. Limited portion is there. Pelton wheel design we will see. In the next lecture, we will see the reaction turbine design. And in the after lecture, one lecture, we will see the introduction about pump. So altogether we can complete our syllabus within a time frame, and then we will see some problems related with this. Tomorrow we will see the problems based on Pelton wheel, and we will start with the tomorrow, day after tomorrow, and we will start with the concept of reaction turbine. Everybody has to complete the task which I am providing on the Moodle, because before 26th I have to submit your FET marks, and all FET marks are dependent on the tasks which are provided on the Moodle. So you have to be clear. You can see your score, and that score will be converted into 20 marks as your FET component. So check what assignments you have missed, assignments are open. You can complete the assignment. One assignment on unit number 5 and unit number 6 will come, which you have to complete before 24th. Okay, and quizzes which I am adding, which are not taking more than 5 minutes. So complete all these things regularly so that it will be easy for me to give the marks to the COE related with your study. And our term is about to end on 22nd, so that later we will have some doubt clearing sessions. Remaining part we can cover regarding overall chapters in next week. So today we will conclude the lecture. Again, I am telling, if you have any doubt related with anything, contact me at any time. Then one more thing, our practical oral examination will be after the end semester examination. So it will not be before the end semester exam. If you don't have any doubt, you can start entering the roll numbers in the chat box, only roll numbers without anything.
सर
हाँ बोला.
जर काय ESC ऑनलाईन होणार की ऑफलाईन होणार आहे?
ऑनलाईन.
ऑनलाईन. ओके सर. आणि सर
टाइम टेबल आले की तुमचं?
पीओई कधी सर लेक्चर झाल्यावर असते आपलं ESC झाल्यावर?
पीओ ही एएसए झाल्यावर घ्यायचं ठरलेलं आहे. इफ इट इज ओपन, जर ओपन झालं, कॉलेज सुरू झालं तर ते ऑफलाईन.
नाहीतर परत ते पण ऑनलाईन?
जर ओपन झालं तर ऑफलाईन, नाही तर ऑनलाईन.
ओके सर.
आणि तुमची ESC झाल्यानंतर एक आठवड्यानं ती होईल जवळपास.
सेकंड इयर आमचं नोव्हेंबर पर्यंत संपणार ना? नोव्हेंबर डिसेंबर पर्यंत.
कुठलं नोव्हेंबर डिसेंबर?
ह्या नोव्हेंबर डिसेंबर पर्यंत.
कुठलं 22?
नाही नाही, सेकंड इयर हो सर पूर्ण.
नोव्हेंबर डिसेंबर कसं रे? अजून एक वर्ष आहे की नोव्हेंबर डिसेंबरला.
वर्ष कुठे सर आली की आता?
आता जानेवारी महिना आहे दाद्या.
ओके सर, आता फेब्रुवारी मध्ये आपलं सगळं थर्ड सेम संपणार. फोर्थ सेमला किती 4-5 महिने.
हो, मग
म्हणजे
जून
डिसेंबर.
जुलैला संपणार की.
हा सर,
जून जुलैला.
जून जुलैला.
रेग्युलर बरोबर येणार तुम्ही.
हा हा.
थर्ड इयर
सर प्रॅक्टिकल एक्झाम 2च सब्जेक्ट्स होणार ना? म्हणजे
2 कुठं रे? एकच सब्जेक्ट की.
फ्लुइड आणि थर्मोडायनॅमिक्स पण ना?
अरे तो सब्जेक्ट एकच आहे रे, लॅब एकच आहे ती.
ओके ओके.
लॅब एकच आहे आपल्याला ती.
ओके,
त्यात
ठीक आहे.
2 सब्जेक्ट जरी असले तर तुमची लॅब ही एकच आहे, एकाच विषयाला लॅब आहे. पीओई.
आणि सर कटिया क्या अडचण?
त्याला ओरल नाहीये. पीओई फक्त
ओके
आपल्या सब्जेक्टला आहे.
ओके सर.
सर ते मॅथचे नोट्स थोडं अपलोड करायला सांगा की त्यासनी.
कसले मॅच कुठले?
मॅथमॅटिक्स.
हा.
ते बोलले की मला अजून क्लासरूमला ऍड नाही केलं.
ओके, त्यांना मुडलला ऍड करतो मी.
मॉडेलला ऍड करून म्हणजे ते बोलले ना सर आम्हाला.
सरना मुडलला एक 15-20 मिनिटात ऍड करतो मी.
ओके सर.
सरांची बोलून घेतो. आणि
काय नसतं तेवढंच. ते सांगायचं होतं म्हणलं मग सांगूया. त्यासनी परवा विचारलं त्यांना, त्यासनी म्हणलं नोट्स
मला
ह्याच्यावर.
सांगायचं रे, डायरेक्ट मला फोन करायचा शिवायला असं जेव्हा म्हणले की नाही, तर हे गोष्टी आम्हाला डायरेक्ट तुम्ही बोलल्याशिवाय कळत नाही रे.
मग म्हणलं मला वाटलं त्याने ते म्हणले सांगतो मी सरासनी का काय बोलले नाही वाटतं.
गडबडीत असतात रे सगळे. मी आता तुमच्याकडनं आलं की मी डायरेक्ट सरांना फोन लावून त्यांना सांगतो मुडलला तुम्हाला ऍड करतो, मुडलला तुम्ही नोट्स टाका.
ओके. आणि सर त्यासनी जरा सांगा की हळू घ्यायला.
का रे?
आणि
अरे आता
होमवर्क
हळू नाही रे, कसं झालंय माहितीये का, आता मी पण आज पास गेलोय.
तसं नाही हो सर, तुम्ही कसं जरा थांबताय तरी 2 मिनिटं श्वास तरी घेताय, ते पण नाही घेत.
अरे आता किती दिवस राहिले? आज 18 तारीख आहे,
हा
22 तारखेला संपवायचंय.
22 तारखेला.
22 तारखेला टर्म एंड आहे तुमची.
अरे 4 दिवस.
हा, आणि अजून माझे 3 लेक्चर मला लागणार आहे.
आणि होमवर्क एक्झाम्पलला देतात ते सोडू पण देत नाहीत, आन्सर पण देत नाहीत त्याचे. तेवढं सांगा की सर, आन्सर तेवढं द्यायला
बोलतो
सांगा.
सर, मला वाटते पुढच्या आठवड्यात एक्स्ट्रा घेता आलं तर बघूया मग.
घ्या की सर.
टर्म एंड झाल्यानंतर लेक्चर घ्यायला जर तुमची परमिशन असेल तर मे बी घेता येईल.
आता काय सर, आपलीच युनिव्हर्सिटी आहे.
तसं नव्हे, आपली युनिव्हर्सिटी आहे पण परमिशन तुमची पाहिजे ना. तुम्हाला पीएल, तुमचा अभ्यास, तुमचं टाइम टेबल आलेलं बघितलं काय तुम्ही?
बघितले की सर.
हा, मग कधी एक्झाम चालू आहे?
31st ला.
मग आलीच की 31st. मग त्याच्या
31st ला
तेच
फर्स्ट पेपर
सांगितलं
आहे.
त्याला, 22 तारखेला टर्म एंड करायचं कारण काय की पुढचं एक आठवडा तुम्हाला अभ्यासाला मिळाला पाहिजे. असं आहे, त्यामुळे आम्हाला त्यावेळेला लेक्चर जरी घ्यायचं म्हणलं तर मग ते एक्स्ट्रा लेक्चर म्हणून घ्यायला लागेल, डाऊट क्लिअरिंग सेशन असं.
बघूया
काय काय होते.
सर ते 3
सर
नंबर
22
ऍड केले
तारखेनंतर
का?
लेक्चर
नंबर ऍड
नसणार
केले
ना?
का तुम्ही पहिले सांगा.
केलं.
हा, काय बोला आता.
सर 3 तासपर्यंत